All right, good morning, everyone. While we wait to see if any more show up, I was telling Jeff last night while we were down in the vendor suite that, I discovered that you can put a canoe on top of your head because it's capsized.
See, the problem is I told everybody I know that joke last week.
I figured it would go around the room. Did you hear about the two antennas that got married? The ceremony wasn't anything, but the reception was amazing. There we go. All right. Well, now that we've livened everybody up.
Comedy Club, everybody.
Yeah. Hey, when you're a scout leader, you got to make sure that the jokes don't come back to you when they get home. So Jeff, as everyone probably knows, is a regional sales manager for the Eastern U.S. with Nautel. Somebody who's, were you like employee 4 or 5, or are you a little later than that?
So I am employee 309.
They had that many people before you showed up?
Right?
Holy geez, Nautel's a long-standing company.
They republished Wendell's article in Radio World this morning. So Wendell, who was our predecessor to Tracy, was 47 years
Wow.
with us.
Long time. So anyway, Jeff took service calls for years before he decided to head to the sales side of the world, and he still does all sorts of presentations. You've now been, according to this, with Nautel for 35 years.
As of 2 weeks ago, yep.
Congratulations. And lots of talk.
I said, don't ever applaud because I was too lazy to look for another job. For 35 years.
There you go. Or maybe you were having too much fun. I mean,
Still am.
I always liked working in the middle of the night. I don't know. Nobody bugged me. Oh, yeah, HR, they want 2 people there now, don't they? Oh, well. I don't know whether you ever got to experience transmitters connected to the open wire feed lines on hydro poles or not.
Mm-hmm.
Oh, yes, those are always fun. So anyway, a wide range of topics that you present on every year, from IT security, grounding, lightning. And I guess, according to this, you still get to play at the transmitter site occasionally.
It's not any fun if you can't blow it up.
Exactly. So, with that, folks, Jeff. Oh, one other thing. After Jeff's presentation, we head down to the vendor room, and thank you to RCS and Xperia for providing this morning's coffee down there. So, Jeff, thank you. Thank you, Nautel.
So he's like grounding, IT security, lightning protection. Let's just talk about it all. So this is site hardening. This is kind of basically a whole bunch of stuff that I've picked up, quite literally from picking up the aftermath after it's been blown up, hacked, cracked, or otherwise molested. I have a little too much fun. We're going to make this open. I'm going to shut this thing off and start yelling at you if my sound guy doesn't get on his volume, Matt. Who's riding gain back there, Charlie?
Me.
There you go. There, now I think we got it good. But I've got the lav on because it's hard for me to stand still at the best of times. The reason I picked this topic, and we started this yesterday, y'all remember the panel where we get talking and we're like, how old's everybody? And only a few people wanted to actually confess to how old they were or weren't. But here's that data I was talking about with respect to the average age of the broadcast engineer. And as you can see, that curve and those numbers are starting to get kind of scary. And again, the SBE is an international organization. This is 2001, 2011, and 2024. Apologize for 2024 map being different. I did that one, not the first 2. But we're getting older. Anybody got bigger budget than they had 10, 15 years ago? Anybody got more people working at the transmitter site than they had 10 or 15 years ago?
Could you just say more people working?
Yeah, all in the same sentence even. It just doesn't happen. We're doing more with less. The good thing is, with the modular stuff today, you can do a lot of it during the day instead of at 3 a.m., although, as Harry said earlier, 3 a.m. is the fun time to work on a transmitter, depending on where the site is. I got one in North Houston that's double fenced, where you pull in, you have to wait till the outside gate closes before the inside gate will open, and the inside gate won't open if the motion detectors see anything in there but your vehicle. It's kind of fun. It's an interesting world.
It's on the ground of the state prison.
No, well, North Houston, it's the same thing.
Yeah.
Josh said it's on the grounds of a state prison, and it's like, no, but yeah. So the whole goal of this was to discuss the things that save you from having to drag your tail out to the transmitter at 3 a.m. on Christmas Eve, like somebody was telling me yesterday. See, the cool thing about coming here is everybody's got stories. How many people have ended up doing an after-hours visit to the transmitter site after working all day at the studio? You ever notice that when you drag in the next morning at 10 or 11, the first question is, why are you late? Not, what were you doing all night? So that's the kind of thing we want to talk about. So grounding. And like I said, this is not going to be an in-depth presentation on any one topic. It's going to be a discussion of a whole bunch of things. But if you look at grounding, the biggest issue that you run into, how many people are running into a site where it may be more than, it wasn't specifically built in the last 10 years for the transmitter that's in there now. You know, you had a transmitter, and then you added a transmitter, and then you removed a transmitter, and this ground got added, and that ground got taken out, and things changed, and sometimes you know where all the grounds go, and sometimes you don't have a clue. In a case like that, sometimes it's easier to rip it all out and start from scratch, which in a leased site can be a real pain in the rear if it's possible at all. And there's the other thing. Leased sites present their own challenges. I was talking to somebody yesterday, no control over their grounding or their air handling. So sometimes you got to make the best you can with what you got. In a situation like that, make your room its own little island. Set up a ground point, single point ground, everything. By the way, if anybody, like I said earlier, if anybody's got any thoughts, ideas, throw your hand up, yell at me, interrupt me. Nobody should listen to me ramble nonstop for a solid hour. So make sure you throw the comments in there as you go. Josh has already figured it out.
Years ago.
He's seen me do this before. So when you're talking grounding, short and straight are the answer. Now here's the other thing. A lot of people will be like, well, I want to use cable instead of strap. The biggest thing to remember with lightning protection is you are playing a current divider game. Remember yesterday somebody mentioned Ohm's law when we were talking about the panel? Everything we do at the transmitter site comes back to E equals I times R. Okay, if you don't have an Ohm's law etched in your memory, that's the one thing. If you learn that, you'll know more about engineering than a lot of folks. E equals I times R, so current divider game. The more current goes through the path away from the transmitter, the less current goes through the transmitter. Sounds easy. Here's the thing to remember. A 2-gauge wire, on average, will have about 2.5 times the resistance per foot of a 4-inch copper strap. 2.5 times means that's that much more current you can route away from the equipment instead of through it. Okay, just something to remember. It's all, now you're going to hit the choke points. You're going to have studs on the ground insulator or ground connection on the transmitter, on the surge box, whatever. But you're looking at the overall circuit resistance, and the resistance per foot of your ground conductor factors into that. Every picture, by the way, that I put up will have something wrong with it, because it wouldn't be any fun if there wasn't a contest involved. So real quick, both those pictures, what's the problem?
Ground straps make a U-turn.
There you go. You don't need a drip loop indoors. Okay, short and straight. So when you're running a ground wire, if you come straight down, go to the top, you've cut a foot off that length of that wire.
Not only that, lightning doesn't do U-turns.
does if you hit it with enough of it, but you're right, there's a high frequency component and you're adding inductance, which further increases the overall impedance of the cable. So short straight runs. Any hams in the room?
I might be one.
Any amateur radio operators in the room? All right. Anybody ever built a choke by taking a piece of wire and winding it through a ferrite a bunch of times? And you know how it works, right? A ferrite is a ferrous material, so it'll saturate. You can create a magnetic field. You get your coil, your inductor effect to attenuate higher frequencies. If you run a ground wire through a steel conduit, which is a ferrous material, you've created a choke. Any high frequency component on that lightning strike is going to be attenuated. If that's the path you want the lightning energy to go, meaning it's not through your equipment, we don't want to attenuate those high frequency components. We want them to go right through. If you can avoid it, and I'm going to quantify this because we're in the home of high-rise transmitter site. If you can avoid it, do not run a single ground conductor through a steel conduit. Okay. Now, a lot of buildings, and I believe CN Tower is one of them, exposed wire has to be in a conduit or a raceway. It has to be protected. Check with the building supervisor for whatever building you're in. See if you can run non-ferrous, plastic, PVC conduit. You can get attachments like conduit nipples that will pierce the insulation of the cable and allow you to bond the cable to the conduit, make the conduit part of your ground system. So there are options beyond just creating a big old choke. Okay, that's the kind of thing that you want to pay attention to. Other thing you want to pay attention to is if you have to cut the footer plate from the building frame away to get to your ground rod, you're probably not connecting to a ground rod. That is the J-bolt that holds the building onto the concrete pad. Concrete does have some level of conductivity. It's got nominally a 50% moisture content, so the conductivity is not infinity, or it's not an infinite resistance. It has some level of ability to pass current. It's a terrible ground. So for reference, anybody here, I know a couple of guys I was talking to yesterday, Q20 transmitter. Remember the Q20? We built those. I know there was a bunch of them around here 15, 20, 30 years ago. So I got called to a site, Springfield, Missouri. And they had a Q20. And they were losing, on average, 1 or 2 of those power supplies every single lightning storm. Those were one of the first switching power supplies we ever did. We built them in-house. They're not inexpensive. Their bill was running $2,000 to $3,000 a storm. In Missouri, where they get a whole lot more lightning than the average part of, like, say, Washington State or Nova Scotia or various other parts. So it was getting pricey. Well, I walk in and the first thing I learned, John Pinks, our chief engineer, one of the founders of our company, wrote our lightning protection paper. And he taught me, he said, start at the tower. Pretend you're 100,000 amps of current looking for a place to dissipate. Your 2 choices are ground, earth, or the AC lines where the power company provides millions of miles of ground. Those are your options. So start following the path back and look for the places you can go. So you look for ground kits on the coax. Ground kits on the coax are a terrible ground because the tower crew almost never scrapes the paint off the tower when they bolt the ground kit on. So there's resistance right off the bat because paint, not that conductive. Okay, you get to the base of the tower. There will usually be copper strap coming off the tower base. Beautiful. In that mythical perfect world, it'll go to a ground rod at the tower base. The strap will go over to a building. Maybe there's a ground kit there, another ground rod. Then it'll go in, should go to a surge protector. Life is good. So we're in Missouri. I start at the tower. No ground kits on any of the coax on a 400-foot tower. Okay, well, like I said, they're a terrible ground anyway, so I'm not going to get too wound up about that. Coax comes down, makes a turn, goes into the building. Nice strap at the base of the tower. Also goes into the building. I'm an inquisitive sort, so I grab a shovel. Because sometimes the funny thing about ground is they put it in, well, the ground. So sometimes you got to grab a shovel. So I start following this copper strap, digging it up. Tower, building, 20 feet apart. No ground rod. So now that 100,000 amps of current comes down that tower, and its only option is coax shield, ground strap, building. No other place for it to go. Oh, this sounds like it's about to get really expensive really fast. So we go inside the building. I'm going to skip ahead a couple. I think, no, I'm not. We'll stop there for a second. So I go inside the building. This strap goes directly to the ground connection on the back of the transmitter. There is a surge protector. It's connected to this. So not to ground. At that point, the only place that energy can go to dissipate is through the switching power supplies and out on the AC lines. I think I may have found the problem. We put a ground rod at the base of the tower. We replaced, that's their AC entrance ground. It's, you can barely see the rod. It's right there. It's driven at about an 80-degree angle. It's a 2-foot rod. It didn't even penetrate the gravel to get into the clay. So, not a ground. We put a ground rod there. Tied the surge protector to that. Tied the transmitter ground to the outside world. And their failure rate went from couple of supplies every single storm to, I was talking to them about a month ago when I was doing Missouri Broadcasters. That might have been 2 or 3 months ago. Time flies when you're having fun. But they've lost a grand total of 2 power supplies in 17 years since I was at that site. That's the difference proper grounding makes. Total cost to implement, 2 8-foot ground rods and a Home Depot hammer drill attachment so you could drive a ground rod into hard Missouri clay. I think we spent $250, plus they get to be the subject of my paper for the rest of my working career.
Which is priceless.
To me, it's absolutely invaluable. I mean, it's awesome. So this is the kind of stuff, and it's funny because the engineer at that group, really good engineer. He had years and years of experience. He's passed away since, but brilliant guy. They were in a hurry, get it on the air, get it up, get it running. We'll come back and deal with the rest of it later.
Oh, that's a bad statement.
How many times, you ever heard the phrase radio station temporary? So, I don't have the vice grips in here, but it's a good example. I've come up to an AM, not in this country. All my best stories come from like Arkansas, West Virginia, et cetera, and so on. But I come up to an AM where the feed line, the copper feed from the ATU to the tower was clamped onto the tower with a pair of vice grips. Yeah, it broke loose. We just clamped it together. We'll get to it. We'll fix it later. I came back 4 or 5 years later. Guess what's still there? But now they're painted aviation orange. Because the tower had been painted and the tower crew's like, okie dokie, painted the whole works. There you go. All right. Other thing about grounds. Picture on the left should be somewhat self-explanatory, but go ahead, tell me what's wrong with that picture.
That must be that new conducting plastic.
Yeah. So the engineer in that particular case was the owner, was the salesperson, was the secretary, was the chief cook and bottle washer, and a buddy of his, when he installed the transmitter, said, if you don't have a ground rod and a pinch, cold water pipe will work. Didn't bother telling him it helps if the cold water pipe is conductive. So, yep, that was a 1 kilowatt transmitter. That was the ground point. Couldn't figure out why it was blowing up. One on the right, station owner, Arkansas. Like I said, some of my best stories come from Arkansas. He's brazing a ground connection, and this comes back to a question that I got asked in an email recently, and we'll get to that in a second. But he's brazing the 2-gauge copper wire that's coming out of the building to the ground rod. And he's doing this at 9 p.m. by the light of the Jeeps, because I had walked through on an inspection about 15 minutes before, reached down and stood up holding the wire in my hand. I hate compression connections with a passion. Hate them, hate them, hate them. The reason is copper is malleable, okay? Copper will compress in a compression connection and deform to displace air in the connection. And as it does that, it will get loose. If you ever put, especially stranded, but even a solid wire in a compression connection, come back a week later, tighten it down. Come back a month later, tighten it down. Come back a year later, tighten it down, and maybe then you can walk away from it. Okay? Hate them, hate them, hate them. Use an exothermic connection whenever you can. CAD weld, love CAD welding. Especially for, like, if you've got a wire going to a rod or a wire going to a wire, you can buy the CAD weld molds for that on Amazon. Think about this. Stuff that is designed to blow up and make intense heat on purpose on Amazon. What an awesome time we live in. By the way, you can buy ferrites in Amazon too now, and we'll talk about ferrites in a bit, but it's an amazing world. So, exothermic bond. My preference is CAD weld. It's really hard to get a CAD weld mold for copper strap. So braze it, silver solder it, silphos, I don't care, but use an exothermic connection. Do not just hammer it over flat and call it good enough, because I promise you two things. Copper is malleable, it'll deform, and the copper will also oxidize, and now you've got a resistor. Remember that part about the current divider game? The lowest resistance we can make the preferred path, the better.
So like 3 drywall screws isn't enough?
Or folding it over and over and over to make an accordion and then stomping it down flat like a certain AM that we both happen to know about. Okay, if you do have an excess of strap, don't fold it over and make an accordion. There's a reason the resistor symbol looks like this. Because you just made a long piece of wire. Remember that whole resistance per foot? The lower you can keep it, the better. So if you have an excess of wire, trim it off, solder it, call it good. If you have to fold a strap over to make a turn, which you do quite often, number one, I like to use 245s instead of a 90 because you make a graduated curve. Like Harry said, lightning energy doesn't like to go around sharp bends. And it will corona off the points at some point, and that's always entertaining until the firemen come. They ruin all the good stuff, but
No sense of humor.
I know, right? So anyway, when you fold the strap over itself, solder the seam, because now you haven't, instead of having a ripple once you get the oxidation built up, you've got a straight path around. Okay? These are little things, but again, we're playing a game that is a matter of degree. If I can drop this to 0.12 ohms relative to 0.25 ohms, that's 1/3 versus 2/3. Okay? If I can make it half again, the ratio gets a whole lot more attractive. So that's what we're trying to do, lowest resistance path. We're in West Virginia now. Lynn Martin's site. I knew you'd know. The saddle clamp is holding a 6-gauge soft-drawn copper wire, AM ground radial, that is hose clamped onto a ground rod. That's on the south side of the building. On the northeast side of the building, the wire coming out from the electrical panel is twisted onto the wire that's hose clamped to that ground rod. On the northwest side of the building, not shown, is the wire hose clamped to the third ground rod that's coming off the transmitter ground. None of these ground rods are connected together in any way, shape, or form except through the transmitter. Earth has a resistance per foot. That means that run a lot of current through here. By the time it gets over to here, you've got X number of ohms of resistance. You've built up a pretty healthy potential difference between that ground and that ground. That can be a problem, especially if one ground's connected to your antenna or your output connector and the other ground's connected to your AC or your ground rod, or in this case, all three. Bonded the three together. Oh, they didn't have a surge protector either, so all the surge had to go through the transmitter, which surprisingly to absolutely no one except the station owner, blew up with annoying regularity. Tied the grounds together, actually brazed that one instead of just having it twisted. Put in a surge protector, total cost in this case about $3,000, and their failure rate went to, surprisingly to absolutely no one, near nothing. Okay, that's the kind of thing, it's the little things that'll get you every time. So I mentioned power line protectors. There's two primary configurations, MOVs, metal oxide varistors, or SADs, silicon avalanche diodes, and I don't care which kind you use. SADs fire a little faster, cost a lot more. For what we're dealing with, irrelevant, don't care. What I do care about is that you have one. Need it, need it, need it. Oh, look, nobody started the clock. Y'all are stuck with me for a while now.
I can solve that.
Too late. Too late. That horse has left the barn. So you need the surge protector because what we're doing, here's the issue. Transmitter sites, almost 100% of the time, are built wrong because the power comes in from the road. We hang the big old lightning rod in the back field. And then we put all the gear we don't want to blow up in between them. So I told somebody if I could turn, this is what we want to get. And I said, if I could take these two pictures and just turn it into a GIF, I could just have it play in there for the entire duration of the conversation. That'd be my whole slide deck. So this is what you start with. This is where you want to end up. Okay, AM, FM, TV, I don't care. Technology, the technique doesn't change. Okay, so the surge protector is the path. Now, a surge protector is bidirectional. It doesn't care. We call them power line protectors, but really it looks at the surge, whether it's a big old surge coming down the tower, which is probably most of them, because you got this multi-100-foot lightning rod in the backfield, or meters. I'm bilingual. I speak English and American. But, yeah, so if you got the big lightning rod, that joke works better in the U.S. If you got the big lightning rod in the backfield, you need to have a path for all that energy coming down, because think about this for a moment. Ground has a resistance per foot. If I run 100,000 amps down that tower and I got 4 ohms per foot, and I'm standing in the field with my feet 2 feet apart, 100,000 amps, 8 ohms. Remember, E equals I times R? That's 800,000 volts between the left foot and the right foot, which is why they tell you to put your feet together if you get caught in the field in a storm. They also tell you to, bend over and kiss your ass goodbye, but that's a whole different discussion. See, I can make jokes too. They're not as good as the canoe joke. That canoe joke is going to live with me forever. So, surge protector is a bidirectional path. Whether it's a big surge coming down the tower that we're dissipating onto the millions of miles of wire the power company provides, or whether it is a surge because we're on the end of the line, Farmer John fired up the irrigation machine, and now we're getting a bunch of crap coming in on the AC lines. Could be either way. The surge protector will either conduct it from tower to power line or from power line to ground. Okay? But it needs to be installed. Now, the ferrites come in at this point because we're using them to increase the impedance of the transmitter, make it a less desirable path. So there's your 3 things: short, straight grounds, surge protector, ferrites. That's your trifecta. The ferrites, to be brutally honest, in spite of my reputation for being the guy that says you got to put ferrites on everything, everywhere, every time, all the time, they're the least important part of this process. If you don't have the short, straight grounds and the surge protector, all the ferrite in the world isn't going to solve your problems. And you are going to have problems. Okay? I mentioned earlier ground has a resistance. You can measure it if you're so inclined. Doesn't matter, because I guarantee you whatever the resistance is, it's going to be a whole lot higher than a 4-inch copper strap. So there you go. There's the relative impedance per foot or resistance per foot for 4-inch copper strap versus 2-gauge copper cable. 2.5 times. Okay, so like I said, if I can run 2.5 times more current through here than through here, that's probably a good thing. It's definitely a good thing. It's short, straight wires. Now, here's the catch. A lot of people don't think. Make the cabling to the transmitter or to the equipment you're trying to protect as long as you can. We want to increase this resistance. We want to decrease this resistance. Okay, so that's the kind of thing you look at. Now again, if you're in a shared site or a leased site, you don't have control over this, all you can do is fix what's in your room, set a single ground point, tie everything to it, hope for the best, put a surge protector in, away you go. But if you're in a field anywhere around, well, Grimsby would come to mind, you have a lot more control over this stuff. Do what you can. And it doesn't have to be expensive. Most of the ground system improvements I've made, well under a couple $1,000s. Sometimes it takes some shovel time. All right. So we talked, that's enough about grounding. I told you I wasn't going to get in depth, but I went and did it anyway. That grounding probably is the one thing that's easy to fix in any site, easy-ish, that will make the biggest difference. Second biggest thing is cooling. Cooling heat probably kills more switching power supplies than lightning. Probably. Okay, 2 things I notice about cooling is there's almost never enough of it going through the equipment. I've walked into rooms where the air was blowing through the room at 100 miles an hour.
Over top of your head?
Or right behind the gear and sucking all the air away from the transmitter. Yeah. So the air has got to go through the equipment, not around it or over it. And it's really cool if you kind of filter it a little bit. Here's the funny thing. So there was a guy working for one of our competitors, not really a competitor, I guess a complementary system, because we don't build liquid cooled and they do. And he used to run around telling people, yeah, liquid cooling's great, it requires 0 maintenance. Horse, pucky. You're putting a heat exchanger outside, and I promise you, at least once or twice a year, you're going to want to go out and clean the crap out of the coils on the heat exchanger, because the efficiency will go to pot, and things start getting toasty. Don't do that. Okay, and this works really well. A lot of liquid-cooled TV transmitters out there, too. So radio TV, like I said, the technology doesn't change. How you cool it doesn't change. Just the degree and the dollar factor when you got to fix it. What do they say? TV is radio with a 0. Okay? Positive pressure is something. Anybody here been to the CJOB site in Winnipeg? Jack Hepner built that a whole bunch of years ago. After the second flood, I think they built the dike around it, which we'll talk about in a minute too. But that site has got so much positive pressure that you have to physically lean on the door to get it to open. It swings inward. The air pressure in the room is shoving the air out every crack and crevice. The only air coming into that building is going through a big old wall of filters, which means that it is clean. You sweep it once and you'll never have to sweep it again. Well, at some point you will. But yeah, so you're not blowing dirt through the equipment. What they did, the transmitters at the time had about a 2,500 cubic feet per minute airflow. They brought 4,000 CFM into the building through a big old wall of filters. They took 3,000 CFM out of the building, directed all the air through the transmitter, and positively pressurized the whole works. At that point, maintenance becomes swapping out air filters. Depending in the spring, dandelion season, things get a little more frequent. In the winter, not so much. Okay, they also put louvers in so they could use the transmitter to heat the room in the winter because it's winter peg for a reason. But that's a whole different discussion. So there's a lot of things you can do for airflow, but make sure the air goes through the equipment. I walked into sites where the room, air-conditioned room, 5, 10, 15 degrees, like well below room temperature, but the transmitter's overheating. Because if you're not shoving that cool air through the transmitter, here's the thing, most HVAC techs will put in an air conditioner and they do it to keep the human in the room comfortable. I don't care if the human in the room's comfortable, I want to cool the equipment because it's what costs money. I mean, the human in the room, it's nice if they're comfortable, but that's not a requirement, especially in an unmanned. How many people have manned transmitter sites?
My ham shack.
Why does that not surprise me?
But by the way, to your point,
Yes.
two ND50s, CFRA, built with a great cooling system that dumped air down behind, kind of a sealed room, built into the wall, hardly ever a fat died.
Yep.
Other ND50 at our other site, there were 2 blowers at the ceiling, and that sucked air in, and another 2 that blew it out, all at the ceiling, and it was just a big room. And until we modified the air system, that ND50 cost us a fortune in fact.
Yep. So, for reference, electrolytic capacitors, MOSFETs, fans, all have a fixed life cycle. Okay, they have lifespan. Fans are consumable. You assume you're going to have to swap out fans and blowers. Okay, it's a moving part. As a rule, they are spec'd for a specific length of time at a specific temperature. Like one of the ones we used at one point was specified to 5-year lifespan at 40 degrees Celsius, 104 Fahrenheit. For every 10 degrees that you decrease ambient, you double lifespan. So at 30 degrees Celsius, that's a 10-year lifespan. 20 degrees Celsius, that's a 20-year lifespan. Now there's a point of diminishing returns because, of course, at absolute zero, everything's a conductor. But for the general rule of thumb, you are going to dramatically improve lifespan when you improve cooling. That means you're going to spend a whole lot less time at the transmitter site fixing stuff at 3 a.m. because it doesn't break as much if you keep it cool. So here's the thing, talking about that airflow direction. Anybody got a mini split? You know, where the air goes out at ceiling height and drifts down? Exact backwards for a broadcast transmitter facility because almost every transmitter out there sucks the cooling air in down below and shoots the hot air out the top. So you either have your cool air doing battle with your warm air and not doing anything down below, or it's just less effective, less efficient. If you can get an HVAC guy to swap that goes into and goes out so it sends the cool air out down low, let's see if I have that. There we go. That's the one I want. Let's get past the stupid animations. Okay. So if we can send the cooling air out low where the air intake is, and then put the warm air return up high, which is ceiling height, which is where every transmitter that I'm aware of, except for the low power ones, dumps the heat, it will save a whole lot of air conditioner cycles. It improves the efficiency. Yeah, it's going to make it a little less comfortable for the transmitter tech standing in front of it, but it's going to make it a whole lot more effective for cooling the equipment. See the challenge, what I was starting to say earlier, HVAC techs are conditioned to talk about cooling the room and cooling the people. I don't care about that. I want to cool the equipment. So they all shoot the cool air out up high and let it filter down, and that way nobody has a breeze in their face and everybody feels wonderful, except the transmitter that's sitting there slowly cooking. Okay, reverse your goes into and your goes out of. Save yourself a whole pile in both air conditioning costs and in repair and maintenance. Okay, the top one is looking at forced air, and like I said, I've walked into more sites where the air's being blown past the back of the transmitter at a couple hundred kilometers an hour and creating a negative pressure zone with almost no air going through the transmitter. Direct the air through the transmitter. In a case like this, I had one where I walked up. I just threw an old hollow core door that was laying there against the side of the transmitter, created a baffle, and forced all the air through the box. And watched the operating temperature of the controller drop by almost 15 degrees Celsius in about half an hour. Remember that whole 10 degrees double the lifespan? Applies to electrolytic capacitors too. Anybody ever had to recap a power supply? Be nice if you didn't have to do it quite so often. Run the air through the gear. All right, there's math. I'm not going to read the screen, y'all know how to read, but learn how to calculate heat loads. By the way, did I put it on here? Let's see, not that one, not that one. I've got a link somewhere, I'll find it. If anybody's interested, let me know and I'll send it to you. John Marcon, used to work with FEBC in the Philippines, did an excellent article for Radio World a few years ago on building cooling, air conditioning, and how to calculate the heat load of the building, looking at the physical structure and all kinds of stuff. If you call the transmitter guy and how much cooling do I need, I will tell you to the BTU per hour how much heat my transmitter generates. I will not tell you at all how much heat your building needs to be removed because of convection heating, because I haven't got a friggin' clue. I'm not an HVAC guy. So if I tell you you need 5 tons to cool this transmitter and you put 5 tons in, don't be surprised the first hot July day where everything overheats and the compressor ices up. Because you got to allow for the convection heating of the building as well, plus any other heat load in the building. Okay? A lot of things have to be factored in besides just asking the transmitter guy how much heat. Going to talk about safety a little bit. I walked into a site in Kentucky one day where I am 100% convinced the local engineer was trying to commit suicide. Every electrical panel had the cover removed and there was loose pieces of Schedule 90 conduit laying around the floor. And I said, nope, not working here, fix this, I'll come back. Okay? Anybody ever hear the saying, nobody ever died from a lack of rock and roll? Take the time to save stuff. If you can find somebody to go to the site with you, back to what Harry was talking about, do that. I tell people they don't have to be an engineer. Grab one of the DJs, grab the GM. All they need to know is where's the circuit breaker and how to dial 911. If they know CPR, that's a side benefit. See, I've been working with this company 35 years now. I've known over half a dozen engineers who were found at the transmitter site dead. Only one of them electrocuted himself. On a transmitter he'd worked on for 25 years, an old CSI that he knew intimately and got a little complacent with. One of the other guys slipped on a piece of, oddly enough, conduit laying on the floor, cracked his head open on an open panel and bled out on the spot. One of the other guys just had a heart attack. Nobody knew where he was till Monday morning. Okay? If you can't have somebody with you, have a call-out plan where somebody knows where you are. When I'm on the road, I've got the Find My app installed on both my phones. My wife knows exactly where I am at any given time. Not to spy on me, but just to know that I'm still up and moving. If I'm not where I say I'm going to be, and I mean, we don't check in daily by any stretch. I've been on the road for 30 odd years. She's used to me disappearing for days on end. But she does like to know, okay, today he's in New York. He said he was going to be in New York. Cool. Why is his phone still in the same hotel 3 days in a row? That's really weird. He doesn't stand still that much. Maybe I should call the hotel. Have a plan. You know, just it can make a difference. Everybody got one of these things, smartwatch, to some extent? You notice most of them have a cardiac monitor on them? So somebody who looks a lot like me was taking the blades off the John Deere recently to sharpen them. Banged my hand, because oddly enough, that's what you do anytime you're trying to take anything apart. Uttered the mandatory string of curse words. Then noticed my watch vibrating just in time to look down and said, do you want me to call 911? It thought I'd fallen. It's like, you ever try to turn off the 911 notification when you're in a panic? However, a lot of these watches do have cardiac monitors. And a lot of them can be configured to automatically call emergency services if you have an incident. Especially if you're working at a transmitter site, make sure that's turned on.
Does that qualify as a transmitter site?
So, we're in Tennessee now. Like I said, there's a region. This is Kason's site. Scott.
It's not Tennessee, that's Kentucky.
Oh, sorry, Floyd's Knob. But
Well, it's not. Yeah.
So that there is a peeled off section of tin roof. There is roughly $160,000 worth of GV40 transmitter sitting under that peeled off section of tin roof with a tarp over it. I took this picture twice over the space of 4 years. The only thing that changed was the color of the tarp. It's easy to say, I'll get to it tomorrow. But tomorrow never comes. See a problem, fix a problem. You know, if you,
Why?
yeah. Somebody said, yeah, but the cool thing is nobody will ever break in to rob anything there because it looks like it's abandoned. There's a certain amount of logic to that. Not good logic, but logic. So, you know, the other thing, mow the field. Up here, you get ticks. Ticks tend to be more prevalent in longer grass than shorter grass. Doesn't mean not, but more common in the longer grass. Floodlights, getting cheaper and cheaper. I have solar-powered floodlights all around the house that got from Canadian Tire for, I think they were $99 a set. They've been up there for 5 years now, so they've paid for themselves over and over again. Okay, cameras. Don't do anything to stop you from being robbed, but at least you'll have a record of it. More and more, I don't know about up here with the OPP, but back home, the RCMP won't even come out if you don't have a visible record of what happened. Cameras are cheap. Shoot, these days you can get a pan-tilt zoom wise cam for $70 off Amazon.
They'll record 4K.
That'll record 4K and stream if you wanted to. Okay? This one may not apply as much here as it does down in the States, but bulletproof peepholes are a thing that I found out about when I went to a site that was equipped with them. That same site, this was in Oregon, actually, sorry, Everett, Washington, close but no cigar. That site, when it was built in a wetland, and the local environauts got a little crazy about it, even though they'd gone through EPA and done all the appropriate permissions and done all the planning. Somebody from Earth First tried to knock down 2 of their towers with a bulldozer. Do you know what level of stupid you have to be to put a D9 against the base of a 300-foot tower to push it over? Because you know where that tower's going?
On top of that D9.
Second one did. Fortunately for the environmentalist, he got out of the way in time, but that tractor was still there when the cops showed up. Oddly enough, it was pretty easy to track by the serial number to exactly who was the owner. Anyway.
I'd have thought you just had to walk the track trail back.
Do it. Yep. Even on the pavement, those things leave a mark.
Oh, yes.
Okay, they also have anti-climb fencing. It's got a 1-inch gap in the chain link instead of 2-inch. You can't climb it with a pair of shoes unless you happen to have hooks on them. And razor wire and all the cool stuff. So I was mentioning earlier about CJOB because they're on the banks of the Red River and they've flooded out a few times, so they built a nice big dike around the site. You had to go up and over to get into the building. And they built it to the 100-year flood mark. Okay? This one on the right, site in Saginaw, Michigan, that was also diked into the 100-year flood mark, except they had 2 100-year floods in a row. Problem with building a dike around a site is after you breach it, you've created a swimming pool. Really big swimming pool. Really expensive swimming pool. The thing to remember, and so back home, Truro, Nova Scotia, we have had 4 100-year floods in Truro in the past 20 years. At this point, you have to redefine what constitutes a 100-year flood. So they've moved the flood mark up a little bit. Doesn't help if your insurance is in what didn't used to be a floodplain and now is, but this is Memphis, Tennessee. This Mississippi River Delta, that transmitter site is 40 feet in the air, and they have had water right up to the landing.
Are they AM or FM?
That one's an AM, KWAM, as a matter of
How
fact.
high up does he put the base insulator for the tower?
Not high enough. It is almost as high, but not quite 40 feet. I think you went 20 or 30 on that. That is that one right there.
Holy
One of the towers. It's a 2 or 3 tower. Josh, do you happen to know?
No.
You haven't memorized every AM in the US?
No.
Okay, so I said we were going to talk a little bit about IT security. Cool thing. So, by the way, Shodan.io, if you do anything to do with IT, is an amazing resource. You can set up a free account. With the free account, once you log in, you can actually specify IP ranges. I use it to troubleshoot my mesh network at home. Make sure that I don't have any leaks, because I have a 16-year-old that does a lot of stuff online. And I've got a real boss who is not afraid to click that link in that email sometimes. Okay, so I spend a lot of time paying attention to my network. So this was taken a couple of years ago originally. There were, at the time, 2,100 barracks units visible online. What do we use barracks for in radio? Okay, fine. What do we use Comrex or Tie-Line for in radio? They're codecs. They're used to deliver audio from over there to over there, quite frequently from a studio to a transmitter site. If I can see your codec, that's a bad day waiting to happen. Okay, this one. They were using port forwarding. All that meant was I just found different ports that I could crack into. Shodan doesn't care what ports you forwarded to. Used to be years ago, port forwarding was at least a fairly decent level of security. Now, when I say years ago, I'm talking 30 years ago, not like last year. Port forwarding is not secure at all anymore. So Shodan is an IoT search engine. And I'm up here searching for, in that case, Nautel. I can almost always find a dozen of our transmitters visible online, and at least 2 or 3 of them will be using the default username and password. So in this particular case, I've got 4 open ports. I've got a barracks codec. I've got an Innovonics Model 731 RDS generator. I've got a Nautel transmitter, and I've got a TP-Link wireless router. At this point, I can control the audio signal going to the transmitter. I can control the power and the frequency of the transmitter. I can control the RDS message getting displayed on every dashboard tuned to that frequency. And I can control their whole network and lock them out of it. Nobody's doing anything on that radio station until they physically come and unplug it and reconfigure it all. We got to get better at this. Now here's the problem. There's a room full of pretty smart people in here. The fact that you're all here means you're probably not one of these people. Okay? But take a look at the network if you're tasked with doing any IT security. Okay? That's it in a very large, oversized, overtime nutshell. Keep it cool, keep it clean, keep it well-grounded, do some safety and security. And hopefully, well, I'll be here next year. And document. Holy smokes, do we suck at documentation. Don't you look at me. I know exactly how bad I am at it. She's like, you need to do this. And I said, I'm not doing that. I did that already. 2 years ago. Yeah, well. Okay, when you make a change, document it. I don't care how, whether you use a spreadsheet or whether you just write stuff down, but document everything. Questions, thoughts, criticisms, concerns, comments? In the back.
How many Nautel trends do you stay on schools on network convention yesterday?
Typically a dozen or so. I think I saw 14 the last time I looked. It varies a little, plus or minus. There's 3 Gates Airs, including a Maxeva UHF TV transmitter in Miami, fully accessible. There's, pick a name. Doesn't matter who. Somebody somewhere has got any product that can be connected to a network, somebody has got it on the public internet unprotected. Somewhere. So that's the kind of thing we need to get better at. Sir?
But fortunately, nobody knows what the default user ID and password is for any of this stuff, not even Google.
So, Google is your friend when it comes to finding this stuff. And I do it the hard way. If I'm looking for Nautel, I will go on Google and look up the default username and password, even though I already know them, just to prove I can find them. Okay? We need to improve. All right. That's it, folks. Oh, whoops. Mandatory thank you slide. There you go. Now it's done.
Any other questions? Oh, Well, I got to admit, your safety point is very well taken. I got an RF burn the other day. It really hurts.
HERTAZ.
Yeah. Thank you very much.
Thank you very much.
Good day, Tom.